So we got 2 blocks fastened to the ceiling of an elevator, as shown in the picture. So the elevator is accelerating upward at 2 meters per second squared. So that's shown right here. We got this upward acceleration. Find the tension in each rope. So I'm going to show you how to do this 2 different ways. First way, we'll treat the blocks separately. Just keep them as they are. So you always want to start with a free body diagram. Oh, and one thing I want to mention here. This is nice because the masses are the same. But like, what if the masses were different? You know, what if this were 10 kilogram and this guy were like 5 kilogram? Then you wouldn't just say, you know, F equals MA. You'd have to specify the mass. You'd have to say like, call this guy M1, call this guy M2 to keep track of the masses. You know what I'm saying? But since the masses are the same, we can just say M, and M is 10. Okay? All right, so let's do free body diagrams. So I'm going to keep the masses totally separate for this first solution. So here's the upper mass, here's the lower mass. All right, so what are the 4? Oh, and we'll call the upper rope, this will be rope 1, and this will be rope 2. Okay? We have 2 different tensions here. 2 different tensions. Which rope has more tension in it? The top rope, because it's holding up 20 kilograms. The bottom rope is only holding up 10 kilograms. So we got tension 1, tension 2. So what are the forces on the top block, the top mass? How many forces are on the top mass? 3. So the 3 forces are, we have the tension from rope 1, we have mg down for the weight of that guy, and mg is going to be equal to 98 newtons, right? M times g, 10 times 9.8 is 98. And then what's the third force? There's something else acting on that top mass. Tension 2. Isn't this lower rope pulling down on the mass? Yeah. You know, so this guy here, this upper mass, has a force holding it up and then 2 forces pulling it down. Its own weight and the tension in the lower rope. Does that make sense? So that, you know, first step, free body diagram. If you don't get the free body diagram right on, there's no way you're going to get the question correct. So you got to identify all the forces. Okay, lower mass. How many forces are acting on the lower mass? We got 2. So what force is acting up? Tension 2, right? The middle rope is holding up that lower mass. And then what's pulling the lower mass down? Its weight, mg, which is 98. Okay, so these are the free body diagrams. So then what do? After free body diagrams, you sum the forces. So we're going to do it for each mass. So we're going to sum the forces for this guy, paying attention to sign conventions. Up is plus, down is minus. That's our sign convention. So for the upper mass, we're going to have T1 minus T2 minus 98 newtons. Right? What did we just do right here? Summed the forces. We just added them up. What is the sum of the forces always equal to? MA. And again, if these masses were not identical, you'd want to say like M1 and M2, right? But since they're identical, we'll just leave it as M. Okay, so we just wrote an equation. Now go to the lower mass. Sum the forces for this guy. So what are the forces on the lower guy? We got T2 up and then 98 newtons down, the weight of the object. All right, what did we just do right there? We summed the forces. What is the sum of the forces always equal to? MA. Okay, and by the way, are these A's the same or different? They're the same because they're connected by a rope. They're both accelerating at 2 meters per second squared. Okay, so now guys, what do we have here? We have 2 equations and two unknowns. If you have two equations and two unknowns, can you solve it? Yeah. So like take this bottom equation right here. Take the bottom equation. T2 is going to equal MA plus 98. When you rearrange it, 98 newtons. So plug in now. So T2, the mass is 10 kilograms. The A is 2, positive, it points up, and then plus 98. So T2 comes out as 118. So that's tension 2. Now come up here to this upper equation. Okay, and keep in mind, we now know what T2 is. So T1 is going to equal MA plus T2 plus 98. Then you plug in. So T1, M is 10. 10 kilograms. Acceleration is 2 meters per second squared. T2 is 118 plus 98. So now we got the answer for T1. That adds up to 236. All right. So problem's done. Now, let me show you one other way to do it. Any questions on that solution? A shorter way, a quicker way to solve this. A quicker way to solve this is, look, this upper rope here, which we're calling rope 1, this is rope 1, this is rope 2. Guys, does rope 1, does the upper rope know that there's two masses hanging from it? What does the upper rope feel? 20 kilograms. So what you can do is just combine these two into one. So here's a 20 kilogram mass, right? If you combine those two masses into one, what are the forces on it? Well, what's holding that 20 kilogram mass up? T1. What's pulling it down? mg, where m is 20 now, so this is 196, right? Up is plus, down is minus, sum your forces. So now you go T1 minus 196 equals MA. There's the equation. So now you can solve for T1. It's a little bit easier, I think. So this is going to be MA plus 196 newtons. What's the M now? 20. The acceleration's 2 plus the 196. So that then T1 comes out as 236. Right? It's a little bit easier. Now how do we get T2? So that's T1. So how do we get T2 now? Well, just go to this guy right here. Go to that guy right there. Do free body diagram. So here's our 10 kilogram lower guy. What are the forces on the 10 kilogram lower mass? mg down, which is equal to 98. And then what's the only force up? T2. Right? So then sum the forces. T2 minus 98 equals MA. Solve that for T2. So T2 is going to be MA plus 98. So M is 10, A is 2, plus 98. So T2 comes out as 118.